Hello, we have another piece of lab equipment for repair. This thing was waiting for its turn for a few months. And it is a voltage and current calibrator by Electronic Development Corporation. The model is 520A/LMSC. I found it on eBay. It was listed for $69. And the description was that it powered up briefly, smoked and shut down. But they had several units for sale, and they all shared the same description, but they had different prices. So I'm not so sure if the description is correct or not. I offered $40 and they accepted, and I picked it up locally. So I spent $40 in total so far on this unit. For this price, I believe it can hardly go wrong. Let's have a closer look at the front panel. We have a power button, a local remote switch, then the polarity switch, then there are 6 decade switches, and then there is a range switch with 4 voltage ranges and 2 current ranges. Then we have output terminals, load and sense separate, and the 1000-volt terminal is also separate, and there is a chassis ground terminal as well. Here is the back of the unit. And here we have a GPIB connector with GPIB address setting switches. Here is some sticker about a modification. This, I believe, is additional output. This is some external strobe input, which looks like a later addition. And I wonder if this sticker is about this modification or something else. Here we have more stickers. This is about warranty, and it has a date, 10/25/85, which is 25th of October 1985. And here I think a couple of stickers are missing. And here we have a fuse, the mains input connector, and the mains input voltage switch. Check it out. Here we have a power supply. These are 2 power transistors on heat sinks, perhaps the output stage. Here we have some option unpopulated. The socket is not populated as well. There are a lot of trim pots all over this board. This is some sort of a sliding switch. And I think this is the reference zener diode. And here we have a sticker about it, saying that it has 6.1588 volts at 6.5 milliamps. Some signs of overheating on the power supply board, but the resistors around here look fine. Perhaps they have been replaced. Here is a better look at the reference zener diode. And check out the precision resistors all over the place. And I wonder, what is this? I have no idea. And here is the sticker I mentioned before. More precision resistors mounted on a separate board. check this out. There is a wire which should be connected to the chassis, but it's not. And look at the green terminal, which is that separate 1000-volt output. It's not connected at all, and I don't see any soldering on it at all. And here is the bottom of the unit, and it turns out that the power supply is not on a separate board, it is the same board. And it looks like some rework was done around here. Perhaps this is one of those yellow relays, and it looks identical to the others next to it. And look at this pad here. It seems like it is lifted. I disconnected the output transistors and checked them, and they are completely shorted, dead short between all three pins. And there are two transistors here which drive them, I believe, and they are also dead. They have short between base and emitter. These two transistors are 2N5681, and date codes on them are 8505, so they seem to be original. And the output transistors are MJ8502 with date codes of 0303, so they must have been replaced at some point. And the fuse is blown as well. A miracle happened again, and I managed to find the manual for the next model, 521, which seems to be very similar to this one. And on the schematic you can see here it says model 520A/521, and here as well. I already see some differences, and the main board layout is different because it's a different version, but I really hope it's gonna give some clue as to what's going on here. Here is the power supply schematic. There are 4 bridge rectifiers. This is the 5-volt rail for the digital stuff, plus minus 15 rails for the DAC, plus minus 15-volt rails for the rest of the stuff, and plus minus 150-volt rails for the output amplifier. And I see all that in the actual supply just fine, but there is additional 12-volt rail here. As you can see, there are 5 bridge rectifiers, and then I see this additional 1500 microfarad capacitor, and on this side there is a 12-volt regulator, and this rail is not mentioned in the schematics at all. Here is this additional 12-volt regulator, and these are 4 15-volt regulators, 2 positive, 2 negative. So now I understand what's going on here a little better. The 1000-volt range in this model is an option, and the module for this, 1 kilovolt module, is not populated in this unit. This is the external strobe input option, which is connected to these 2 terminals on the back we've seen before. This thing is a precision divider for the 100 millivolt range, and this sliding switch is 6-position switch for the voltage limit in the current mode. It is set to the maximum now, which means the voltage on the output terminals is limited to 100 volts in the current mode and can reach up to 150 volts if the circuit is open, which is the limit of the power supply. And in the minimum setting, the voltage is limited to about 1.2 volts, and for the open circuit it is limited to about 11 volts or so. Let's have a brief look at the block diagram. Here we have a 24-bit DAC with a separate power supply. The DAC is controlled through opto-isolation by the microprocessor unit with the input from the front panel or GPIB. Here we see the 5-volt supply, and this is the external strobe option. The output of the DAC goes through the polarity switch to the output amplifier, which drives the output terminals and receives feedback from sense terminals. And here we see the power supply for the output amplifier, plus minus 15 volt rails and plus minus 150 volt rails. So, how do we proceed? Apparently the output amplifier is blown, so I think the easiest way would be to try without it for now. So I think we can disconnect the plus and minus 150 volt rails and try powering the unit up to see if it would show something on the display, if we could change the voltage, if it would affect the output of the DAC and such. So let's just desolder the wires from the transformer over here to the 150 volt supply and give it a go. I desoldered the wires from the transformer and installed a new fuse. Let's see what happens. Check this out. It's working. It shows this overload because there is detection that nothing is on the output, so it assumes that there is too much load. It's another day and I left the equipment running overnight because I couldn't resist the temptation to measure the reference zener diode. There is a note in the manual not to measure directly across the reference zener, but use the indicated test points. Here is the drawing, and as I mentioned, the board layout is different, but the relevant parts are the zener diode and the capacitor right next to it. One test point is on the anode of the zener, and the cathode test point is on the capacitor right next to the zener. I'm not sure why it should be done this way, but that's what I'm doing. So we are reading 6.15826. And note the temperature in the lab, 24.6 degrees, and my probe is hanging right over the zener diode. So here is our reading, here is what we saw on the tag, and unfortunately they didn't specify the temperature at which they took this reading. And this translates to about, if we round up, 88 ppm below. Let's look at the specs of my meter. If you watched my recent videos, in one of them I repaired another voltage calibrator, which was Fluke 341A, and in that video I compared my meter side by side with a new model 34461A, which had a certificate of calibration within 1 year, about 1 year, by Keysight. So let's assume my meter is in calibration, because the meters agreed almost perfectly within a few microvolts. So on this range, 10 volt range, we have 1 year 35 ppm of reading plus 5 ppm of range at 23 degrees C, plus minus 5 degrees. So roughly speaking, it is about 40 ppm. And here are the specs for EDC 521. Unfortunately, I don't have specs for 520A. I will have to assume that they are close enough. Perhaps 520A is slightly worse. Let's see. Accuracy here is specified at 20 ppm of setting plus 5 ppm of range plus 3 microvolts. And there is a note that 3 microvolts primarily applies to 100 millivolt range. And because we are not measuring the output but the reference zener diode, I think we need to take this base accuracy of 20 ppm, and the stability for 1 year is also 20 ppm. So we have about 40 ppm roughly of uncertainty about the meter, and about 20 ppm of uncertainty about the calibrator. And you see, the meter is not really appropriate for this job, because it is less accurate than the unit we are trying to test. But that's the best thing I can do at the moment. So we have a total of about 60 ppm of uncertainty, and we are more than that out. I'm not quite happy about this, but it's not too bad considering that the unit was manufactured in mid-80s, and I have no idea about history of calibration and adjustments and stuff like that. Now I'm measuring the output of the DAC right here. And as you can see, we are reading about 1 or 2 microvolts at 0 setting, which looks perfect to me. Let's try changing that. This adds about half a volt negative. Looks perfect to me. This adds about 50 millivolts. This adds about 5 millivolts. This adds about half a millivolt. This adds about 50 microvolts, slightly lower, and this should add about 5 microvolts. And it does not quite do that, but we are down in the noise. Overall, this looks great to me so far. This means the DAC is working just fine, and now we need to fix the output amplifier. Here we are. I have replacement parts. I couldn't find these MJ8502 transistors, at least for a reasonable price. And by the way, they are MJ8501 on the schematic. So I looked through some cross-references and found that BU208A are equivalents. So I ordered a pair from China on eBay for about $5, and I hope they are not fake. To replace these 2N5681, I ordered 2N5682 on Mouser, and these are identical to 81s but can handle slightly higher voltage, and they were $4.50 each. And by the way, I was wrong that they have shorts between base and emitter. Here is a 3.3 ohm resistor between base and emitter, but they are dead anyway. They are completely open. And I also found that one of the diodes was shorted. There are two diodes in series here and two here, and one here was shorted. So I got replacement diodes, and now I'm hesitating. Should I replace just this one or all four? Here is the datasheet for 2N5681 and 82. And as you can see, they have the same parameters except the voltage. 82s can handle 120 volts and 81s only 100. So I thought it was a good idea to order these, even if these were available for about the same price. Here are the data sheets for MJ8502 and BU208A, and it seems like these exceed these in almost every spec. The maximum voltage 1200 volts here, 1500 volts here, this other voltage 700 volts here, and the same 700 volts here, emitter base voltage 8 volts, 10 volts, collector current 5 amps, 8 amps here, peak current 10 amps, 15 amps here, power dissipation 150 watts is the same as here, 150 watts for this package, TO3. So looks fine to me as a replacement. And by the way, I think these transistors are grossly overspec'd for the job. Alright, new transistors are installed. All four diodes are replaced. The transformer is connected back. Time for a smoke test. Alright, no smoke so far. Let's check the output. We are on the 10 volt range, 0 setting, and I see this offset of 265 microvolts. Well, let's try 1 volt, 2 volt, 3, and so on. Seems to work just fine. Now let's go to 100 volt range. 10 volts, 20, 100 volts. So it seems to work just fine, and perhaps just needs some adjustment, or it needs to be warmed up. And this is the 100 millivolt range, and the offset here is only 3 microvolts. 10 millivolts, 20, and so on. Works just fine. After warming up for several hours, the offset only increased to about 310 microvolts, and this offset does not change the polarity. And I think it means that the 0 point of the amplifier has to be adjusted. Here is the adjustment procedure, and the second step here is precisely about this 0 point of the amplifier. At 0 setting and 10 volt range, we are supposed to switch the polarity back and forth and adjust R17 so that the magnitude is the same but the polarity is opposite. Here is a note about that. R17 is adjusted for equal magnitude but opposite polarity. But we have the same polarity. There is a problem with this adjustment procedure though. I don't see these designators on the schematic at all. Here is the schematic for the DAC, and this is the reference circuit. And I think the potentiometer for the first step to adjust the zener diode voltage is this one, but it's not R11 but R181 instead. And this is the output amplifier schematic, and I think I found this R17 for the second step to adjust 0 point of the amplifier. But I see a difference here with my unit. Here on the schematic I see this second pot and this relay contact, and this is to adjust 0 point of the amplifier for the 100 volt range, and there is no such thing in this unit at all, and not even a place for it on the board. I took a closer look at this drawing of the adjustment and test points and compared with the actual board, and now I see that only this area does not match the board, and if we rotate this part like so, this pot would move over here, and here it is. And this precision divider will rotate like so, and here it is. And the rest of the pots are in their places, and everything makes sense. Check this out. I've got another Hewlett-Packard 34401A meter, and I warmed up the equipment for several hours and switched the meters into a slow mode, so it takes them several seconds to settle, but makes the comparison easy. So the last digit is 1 millionth or 1 ppm, and as you can see the meters disagree by about 1 ppm in this range. But the calibrator is out by about 810 ppm, which is way too much. It definitely needs an adjustment. And let's go to 10 volts. Wait for meters to settle. There you go. And in this range the meters disagree by about 5 ppm. And the calibrator is out by about 540 ppm. So I'm quite happy that meters agree this closely, and strictly speaking such comparisons don't mean much, because you never know, the meters could have drifted the same way, but still I think it helps to build up confidence in my meter. So let's assume my meter is perfect and go through the calibration procedure. The first step in the calibration procedure is to set the zener diode voltage to the voltage on the tag, which should be 6.1588. There we go, done that. The next step is to adjust the 0 point of the amplifier, as we've seen before. So we need to set in the 10 volt range 0 setting and switch the polarity back and forth and adjust the potentiometer so that we have the same magnitude but the opposite polarity, which is not the case right now. We have about the same magnitude, not quite, but the same polarity. And here I think I've done my best. We have about negative 12 microvolts on one side and about positive 12 microvolts on the other side, and the polarity is reversed. Negative here is positive here and positive is negative here, which is okay. This is even mentioned in the manual that it doesn't have to be the same. The next step is to adjust DAC 0 so that this magnitude is below 10 microvolts. Alright, I've done my best here. The next step would be to adjust the 0 point of the amplifier for the 100 volt range, but as we've seen before, there is no such adjustment in my unit, so I will have to skip this step. And the next big step is to go through all positions of the most significant digit and adjust these trim pots to have this voltage within this tolerance. Alright, the big step is done, and now we need to adjust this 100 volt range full scale to be within 500 microvolts. Alright, this step is done as well. The next step is to adjust full scale on the 100 millivolt range to be within 2 microvolts, and it is already there. So the next step is to adjust the current ranges. For this we need a precision 100 ohm resistor. Let's see what I got. And this is the best 100 ohm resistor I have at the moment. 5%, 3 watts, and it happens to be within 0.1%. Should be good enough. So now in the 10 milliamp range we need to adjust this reading to 1 volt plus minus 20 microvolts. Alright, I adjusted, but not to 1 volt, but to the value of resistor 99892. And now we need to do the same in 100 milliamp range. So, and I need to adjust the full scale for this range. And this is tricky because the resistor starts heating up and drifting pretty quickly. So I do it for brief periods of time. Should be good enough. Perhaps a better idea would be just to short the output through the amp meter. I left the equipment running overnight and it still seems to be in spec. There you go. I hope you enjoyed this video. Thank you for watching. Bye.